Hey, what's up, everybody? It's Mr. Hutch here, and I'm here to talk about area of composite figures. I miss you today. Hope you're having a wonderful day. Make sure you're not doing anything that you shouldn't be. You know who I'm thinking of. I'm not really sure who I'm talking about, but anyway. All right, I'm gonna move really fast through here since you can like pause and things like that. So the first bit here, what we're doing, we're talking about composite figures. A composite figure is made up of two or more shapes, and we're going to be decomposing those, meaning take them apart, okay, decomposing. So decomposing them. So we need to understand the area formulas for each of these shapes so that when we do recognize them within a bigger shape, we can find the areas of them and then add them together. Okay, so a recap here. I want you to write the shape name first. So we have parallelogram. And we're going to write what its area is. So area, we can see over here, is a nice simple one, is base times height. And I want you to be aware that our base is there and our height is perpendicular to that base. It's not on the angle, okay? So it forms a 90-degree and is perpendicular to that base. That's what the height is, okay? So area, base times height. Next one is our triangle, obviously. Triangle is base times height, but cut in half because it's half of a parallelogram, okay? So let's go ahead and write the shape. So we have triangle, and as area is 1/2 the base times height, or you could do area equal, make sure you put equals there, sorry. Base times height divided by 2, same thing. Next one is a trapezoid, so that's there. Be aware your bases are your two parallel lines. So a trapezoid has one pair of parallel sides. Okay, so this with this, that's base 1 and base 2. You can see the height is still perpendicular to the base. And so we have trapezoid, and our formula for trapezoid is area equals 1/2 base times height. Okay, but the base, there's two of them, so we do height times b1 plus b2. Okay, but really it's 1/2 base times height. Okay, but you have two bases there. Okay, and then our next one is obviously a circle, and we know the area for a circle. Let's go ahead and write circle is area equals pi r mini 2. Okay, so when we're decomposing something, we would just look at this and be like, oh, I see a rectangle here, so I can find the area of a rectangle, and then I can find the area of, let's see, we have two parallel lines of this trapezoid. Okay, and then you would add those two areas together and get a total. Okay, all right, so that's what our focus is today. Okay, I'm going to just keep my formula sheet off to the side here. Let's go ahead and I feel like I'm just talking a little quick here. I want to like slow things down a little bit. Check out this really cool, it's just like a relaxing car drive. It just like seemed peaceful to me. I want you to see it. Look how calm. Does that just bring you peace? Sorry. Sorry, that just made me laugh. Anyway, all right, back to here. All right. I always like a good jump scare randomly. Area of composite figures. So here we go. We have two figures in here. We can see the rectangle and we can see the triangle. So all we do is do area for the rectangle. So we'll set up the rectangle first. Okay. And we're going to write the formula. So area equals base times height, and then fill it out. Don't be lazy. Actually write this out. Pay attention to the base, though. Okay, the base is not this length. It's from here to here. Okay, and so we have 14.5 inches is our base. I'm going to put it in parentheses here, times the height of 4 inches. Okay, and we can go ahead and calculate that area with our calculator. 14.5 times 4, and we get 58. We want to get all of our points, so we're going to put inches squared. So I'm going to go ahead and mark that in here, that this area is 58 inches squared, and then we're going to add it with the triangular area. Okay, so the area of a triangle is 1/2 base times height. Okay, it's half a parallelogram. So my base is this here. Okay, and I know that's 4 from over there. Okay, and then my height, remember, runs perpendicular to that base. Okay, and so I need to know how long that is. And since I know that this is 14.5 from here to here, I know this whole thing is 20.75. All I have to do is subtract to find that leftover length. So let's go ahead and do that, 20.75. So there's a little bit of logic that has to go on for finding the measurements, and you want to be really careful about that. So that's 6.25 is this distance. Okay, and so now we have the information we need. So let's go ahead and do our triangle. That's area equals, we're always going to write our formula, 1/2 base times height, and then go ahead and fill it out. Okay, no being lazy. Our base is 4. We got to do some parentheses here, and our height is 6.25. Multiply it all up. We got 6.25 times 4 equals divided by 2, which is times 1/2, and we get 12.5. So area equals 12.5, and that's also in inches squared. All I'm going to do is I'm going to add up my two areas, and let's see what we get. 58 plus 12.5, and we get 70.5 inches squared, and that is my official answer for the area of that entire shape. Okay, composite figure we call it. Okay, so that's how that works. Let's go down here. You can try this one out. Go ahead and try it on your own. You can pause the video right now if you want, and then I'll work through it pretty quickly and you can check your work. Okay, go ahead and pause if you want. All right, so I see two shapes, rectangle, semicircle. I know area of a rectangle, and if you don't know, then you look, okay, or go to the top of this page. Area of a rectangle is area equals base times height. We're going to write that first. I know that my base is 1.5 feet. I don't need to write feet. And my height is 2.25 feet. Let's go ahead and calculate that. 1.5 times 2.25. And I get an area of 3.38 because we're rounding to the hundredth. Units is feet squared. Okay, now let's go ahead and do that semicircle. I know the area of a circle is pi r squared, so a semicircle is going to be half of pi r squared. Okay, so we have half pi r squared. Okay, I know this entire diameter, so we're not putting diameter in for r, we're putting the radius. Okay, so make sure you plug in half of that. So 1.5 divided by 2, the radius is only 0.75 from here to here. Okay, so you just got to be careful about stuff like that. So I have 1/2 times 3.14, and then my radius is 0.75 squared. Okay, so 0.75 times 0.75 equals, and then times pi, 3.14, and that's the area of the entire circle. I need to divide by 2 because it's a semicircle. And so I get 0.88, because we're rounding, 0.88 feet squared. Let's add those two shapes up, boop, boop, and we get 0.88 plus 3.38, and we have 4.26. So area of the whole thing is 4.26 feet squared. Circle my answer, and I feel magical. That was really dorky to say, but whatever. I'm tired, and sitting here in a room by myself recording for you because I love you all. All right. I'm probably sitting eating Chick-fil-A right now while you're at school, sitting here listening to me. Area of shaded region. So we've talked about this before. We can find the area of the whole thing, find the area of the circle, and then subtract out the circle. Okay. So let's go ahead and find the area of the rectangle first. So let's do our rectangle. We know area is base times height for our rectangle, okay, or just length times width, okay. Same thing, really. And so we have area equals 8 times 6, okay, and so 6 times 8 is 48 meters squared. Let's go ahead and do our circle. Okay, we know an area of the circle is pi r squared. And so let's fill that out. Notice how I'm writing the formulas. You need to do that as well. No being lazy. 3.14 times the radius. Now look, they're giving you the whole diameter, so the radius is only 2. Okay, so 2 times 2 is 4. And 4 times 3.14 gets us 12.56. So area equals 12.56 meters squared. Okay, so I want to remove that white circle out of the rectangle. So we're going to do our 48 minus the circle. Okay, and let's see what's left over of our shaded. Take out the circle, and we have 35.44. So the area equals 35.44 meters squared. Okay, and this is shaded, just so I'm labeling well. Okay, so that's how you do those. Okay, here's another example, same idea. Okay, we have information for a circle, and you can see they're giving us the radius here of the circle. We also can see the length of this square. All 3 corners are 90 degrees. We can tell because it's within this circle that it's actually a square, okay, because from center to the corners are all 6 meters, so it has to be a square, otherwise that would be different, okay. All right, so let's go ahead. We need to get the area of the entire figure, and then we'll go ahead and find the area of our white and subtract, okay. So let's go ahead and get the whole circle. So for the circle, area equals pi r squared. Plug in what you know, 3.14. Our radius is 6 meters. That's definitely a radius, not a diameter. Squared. So 6 times 6 is 36, and 36 times pi is an area of 113.04, and that is meters squared. Okay, so that's our circle. Look at all the labeling I'm doing. Okay, I'm paying attention to what I know, what the formula is, filling things out, and labeling what it is so I don't lose track. Okay, let's go ahead and get the area of the square inside. Okay, so let's go ahead and do square. So I'm going to label that. We know the area of a square is your base times height, really. Your length times width. Since they're the same, it's just one of the numbers squared. And so I'm just going to go ahead and write area equals base times height, same thing again, length times width, whatever you want to do, same concept. So it is 8.5 by 8.5, or 8.5 squared. That's why they're saying over here, they're saying s squared, okay? But it's all really the same. I mean, it's 8.5 times 8.5, okay? So let's go ahead and get our area. 8.5 times 8.5, and we get 72.25. And that is meters squared. So I know my circle, I know my square. Let's get rid of the square to find the area of the shaded. Okay, so find the unshaded, that's right there. Find the area of the shaded is 113.04 minus the square, and all that equals 113.04 minus the square, 40.79. What's my units? I want to get all my points. Meters squared. So area, and that is shaded. Okay. All right, so here's one for you to try. Find the area of the shaded region. Okay. So let's go ahead and take a look at what you see here. So one of the things that you have to start off with is go, okay, like what shapes do I see? So first of all, I see triangle, triangle, and triangle. But that's 3 things of work, and I think I can do this in less. So the other thing I see is I see a large trapezoid like this, and then I see a small triangle. So really, all I have to do is find the area of the large shape, find the area of the one triangle, and then subtract. So I think I would tackle it that way instead. Okay, trapezoid is one that we didn't do yet. Okay, so if you look at trapezoid, it has the biggest formula for area. Okay, and so that is, let's go ahead and do our same process here. Oh no, I just got rid of my circle. So let's do trapezoid first. Is area equals 1/2 of the height times B1 plus B2. Okay, so again, really it's half of base times height. Okay, but there's 2 bases. There's a base right here and a base right here. Okay, and they're actually giving us both of those, which is really nice. Okay, so fill out everything. Area equals 1/2. The height, okay, is my distance that's perpendicular from my bases like this, which I see is 15. Okay, so here's my height is 15. My B1, okay, it doesn't matter the order. Okay, I'll just do 18 plus 8 plus the other base. Okay, we're going to go ahead and do our 18 plus 8 because that's inside parentheses, and that's 26. And then we have times 15, and then all of that times 1/2 or divided by 2. And we get area equals 195, and that's feet squared. Okay, now let's get that little triangle, which is 1/2 base times height. So we have triangle, area equals 1/2 base times height, area equals 1/2. Our base is 8. Our height that's perpendicular is 15. Okay, so we have 8 times 15. Put those things in parentheses. Okay, so 8 times 15 divided by 2. 8 times 15 divided by 2. And we have an area of 60 feet squared. Now, we only want the shaded, so we're removing that white triangle by subtracting. Okay, so here's my giant subtraction symbol. Okay, and we end up with 195 minus 60 is 135 feet squared shaded, and that's what you should have. Okay, all right, we have 2 more, and then you're on to your homework. Okay, so here is an application one. It says the members of a community center are planning on using ceramic tiles to create a mosaic. One tile covers 2.5 square feet. Okay, how many tiles are needed to make the mosaic? Okay, so here's one annoying thing that I'm going to tell you, is that one tile covers a weird amount of square feet. That's really stupid and annoying, because one tile isn't covering 1 foot to make it really nice. So we'll get to that in a minute, but I want you to be aware of that. That is a funky situation. So first, let's just find out how many square feet there are, and then we can go ahead and divide that up. Okay, so we're identifying shapes. So take a look at this and like see what shapes that you notice out of here. Obviously, I see a an octagon anyway, but we don't have the formula for an octagon, so I am going to decompose it. Let's see. I mean, we could cut it this way, and maybe we have all those measurements. We could also cut it this way, right? And maybe we have those measurements for the two trapezoids. And the two trapezoids are the same, so that's sort of like convenient. So you want to look also, do you have the length and width or the base and height of that rectangle too? And I think we do have everything we would need with this. So we should be pretty good to go. Okay, so let's try this out. Okay, so we have two trapezoids. Luckily, they're the same. Okay, so think about your formula. Your formula at the end is going to just be doubled because we have two of them. Okay, and so that'll work nicely. Let's go ahead and set that up first. So we're going to do our trapezoid. So again, back to labeling. Formula for a trapezoid is that weird one. It's the same as a triangle, 1/2 base times height, except we have base 1 and base 2. Okay, so area equals, let's try, instead of writing 1/2, we'll do the divided by 2 version. So we have base times height, or height times b1 plus b2, and all that is going to be divided by 2. Okay, so I'm just rewriting it that different way. Same thing though. Okay, let's look at my trapezoid. What is the height? Remember, the height is perpendicular from the base. Okay, so it forms that perpendicular from base to base, and you can see that distance is 5. Okay, so I know what my height is. Okay, it's 5 feet. Base 1 and base 2, it doesn't matter what you pick. Okay, just make sure you get the correct numbers. So I can see one of the bases is 10, and the other base distance, we can see that length is 18. So we're using 10 and 18 for these. 10 plus 18. All that is going to be divided by 2, okay, or multiplied by 1/2. So let's go ahead and do that. Parentheses first. 10 plus 18. I don't know why I'm typing it in the calculator, but times 5. And then all that divided by 2. And we get an area of 70. Let's look at the units, and it's feet squared. Now, I have 2 of those trapezoids, right? Okay, trapezoid 1 and trapezoid 2. So really, we can just double this, and we know that the area of both of our trapezoids together is 140 feet squared, if we add those up, okay? All right, now let's go ahead and do our rectangle, okay? And I'm going to get rid of orange because it's, like, weird. All right, ooh, green. Rectangle formula, area equals length times width, okay? I'm just going to use base times height, same idea. Do we know our 2 measurements? So let's look. So I have 20 by, what is this? We know that this, it's not 10, okay? This whole length is 18. So be careful, we're talking 20, go away light, there we go, 20 by 18. Okay, so you just got to be careful when you're doing that. So area equals 20 times 18. Let's go ahead and calculate that. 20 times 18, and we have an area of 360 feet squared. Okay, let's go ahead and add our 2 things together here, and we get 360 plus 140 equals 500. So we have an area of 500 feet squared. Okay. So we'd think that that's our answer, except they're being extra dumb with us over here, and they're saying, hey, we have these tiles, and the tiles cover 2.5 square feet. So we need to divide up these 2.5 square foot tiles with this space to actually find out how many tiles we need, because someone decided that a tile shouldn't be 1 square feet, which would make this really nice and easy because we would just buy 500 of those tiles. But anyway, whatever. I don't know whose idea that was to make a tile 2.5 square feet, but that's what they chose. So let's go ahead and divide this whole thing up by 2.5 and figure out how many tiles we actually need. So if we take our 500 tiles and we divide by 2.5 foot tiles, we end up with 200 tiles are needed. So just be careful about some like life application, things like that. They are doing that to try to trick you. Okay, here's one for you to try. Hopefully you can see those two very obvious shapes and you should slice it there. You have a trapezoid and a rectangle. So go ahead and give that a shot. They're letting you know that a case of decorative stone costs $25 and only covers 6 square feet. So you're going to be dividing up into 6 square feet to figure out how many stones will fit in there. And then each of those stones, each of those 6 square feet is a case of stones. So we need to figure out what the cost is for all of those. So you sort of have a extra step here. Okay, so go ahead and pause. You can try it out and then unpause and you can check and follow along, or just follow along. Either way, I don't care. Or you can even pause it and then just scroll through and check your work. All right, here's what you need to have, though. I will be checking this on Monday, so make sure you have everything the way it needs. Otherwise, I'll make you watch this again. All right, let's take care of the trapezoid first because that's more annoying, and I like getting rid of the annoying things first. So we'll start off with trapezoid. Area is, remember, the same thing. I keep doing that with my A's for some reason. This like double line. I don't know why. Area is the same thing as a triangle. So area equals 1/2 base times height, except we remember we have 2 bases. So we have 1/2, and we do the height first, and then B1 plus B2. Okay. And then fill out everything that we have. So what is remember the height is perpendicular to the base, and we can see what that is. It's 4.2. So we have 4.2, and then B1 plus B2. One of our bases is 13.65. Okay, and our other base amount that's red, we can see down here is the same length as that. So we have 4.2. Okay, so that'll get us area of our trapezoid. Let's fill all that out. 4.2 times 13.65 equals times 4.2. Did I already do 4.2? I feel like I did. Oh, yeah, those are the same. I just thought I messed up because I saw 4.2 again. 4.2 times 13.65 times 4.2 again equals that. Divide it by 2 or multiply by 1/2, and we have an area for the trapezoid of 120.39 feet squared. Okay, so that's trapezoid. Okay, now let's go ahead and do our rectangle. So we'll do that over here. Rectangle. Area equals length times width, or I've just been doing base times height, so I only have to remember one thing because that's way easier. Area equals base times height, so we have 4.2 times the height of 6.3, and there we go. It's a nice easy formula. 4.2, 6.3. 4.2 times 6.3, 26.46. 26.46. I want to get all my points, feet squared. All right, let's add up our two areas. So plus 120.39, and we get 146.85, 146.85. So that's our total area, okay? And that is feet squared, okay? Now, let's deal with this nonsense, okay? A case of decorative stone, okay, covers 6 square feet. So how many cases do we need if we have 146.85 square feet? So let's go ahead and divide up our total area with 6 square feet. Okay, so divided by 6, because I already have that in my calculator. And I need 24.475 cases, but you can't have part of a case, really. So I'm going to go with I need 25 cases. Okay, because you can't do a partial case more than likely. So let's do this, because that's the way real life works. If I have 25 cases, one case costs $25. So what am I going to have to do with my 25 cases? If you said multiply by $25, remember $sign goes in front, not after, then you would be correct. And 25 times 25, do you know what that is? It's $625. That's That's a lot of money for stone. Holy moly. Okay, that better be magical unicorn stone. All right, so that's how much it will cost, is $625. Okay, pause and reflect, please. All right, here's your independent practice now. If you want to work with a partner on this, you can. Find the area of each figure. Use 3.14. You can see example 1 is what you're going to use for 1 through 6. Okay, really make sure that you're decomposing those the best way possible, as simple as possible. You, from the looks at it, should only ever be looking at 2 shapes. Okay, for all of those, area of 2 shapes, adding them together, that's it. Okay, and then number 7 is like example 2. Okay, so find the area of the whole thing. Okay, that's one big rectangle area. And then find the area of one of these white squares. And look, they're just the same. So you would then just double them and remove them out of the shaded area. Okay, same thing here. Find the area of the big trapezoid. Find the area of the one triangle and subtract it and remove it out of there. Okay, so that is your work today. Anything not done is homework. You also have your IXL to do on this, so get working. You have this time and you have tutorial and all that. If you need some help with something, I am going to be having so much fun in Ohio, but I am happy to answer your questions. So shoot me a message and I can help you out, or drop in on Alexa or something like that. So, all right, have an awesome day. Miss you guys. Wish you could be with me. That would be cool. Maybe next year. All right, talk to you later. See ya.